Ooh, all right. Good morning, Ocean Rangers, and thanks for joining us for another Summer Kids Club this morning. My name is Kaya. I'm coming to you live from the Aquarium of the Pacific, and today we are going to be talking all about a really amazing and cool and maybe underappreciated group of animals. Yeah, we're going to be talking all about invertebrates and all of their cool adaptations. Now, if you're not sure what an invertebrate is, don't worry. We are going to start off by defining what that is and then taking a look at some of these different groups and some of their amazing adaptations. Now, while you're watching, I would love your participation. If you would like to text in any of your questions, feel free. 562-286-1838. I have James who's at the computer ready to take any of your questions. I also have Jen in the studio here who's going to make all of the amazing things behind me happen. She says hi to you as well. And of course, if you're watching this later, then you are welcome to email us live at lbaop.org and one of our educators will get back to you as soon as we are able to. Now with that, let's go ahead and get started thinking about invertebrates, which is right behind me, actually. I have a whole big group here. Do you recognize this animal? They are jellies. All right, but I want to actually pull up this word to talk about it in case it's a new word for you. So here we go. Invertebrate. If you want to say that with me, go ahead. There we go. Invertebrate, everybody. So what does this word mean? Now, it might seem like kind of a big word, but it actually means something pretty simple. All this means is that invertebrates are animals, living things that don't have a backbone. So if you want to take a moment and feel your backbone, which I think is a good way to start, you might feel that it's a little bit bumpy, right? So all of those bumps are called vertebrae. So because we have that, we are called vertebrates. Now, animals that don't have that are called invertebrates. And there's so many animals out there that don't have bones on the inside of their body. Now, if I were to ask you, what's your favorite animal? I have a feeling you might say something that's a larger animal, maybe like a cat or a dog or maybe an elephant. When we tend to think of animals, we tend to think of animals with backbones. But 90% of all of the animals out there actually don't have backbones at all. So we're going to be taking a look at some of those different groups of animals, invertebrates that live in the ocean, and think about how they're able to live. All right. Now, once again, any questions you have, please text me 562-286-1838. I'll be happy to get to any of those. Now, invertebrates. What is the first group that we're going to be talking about? You would think it would be the jellies because that's what I have behind me, but I'm actually going to do a totally different type of invertebrate here at the aquarium. We're going to be talking first all about crustaceans. Who's heard that word before? Ooh, a great crustacean right here. Now, again, this word might not be very familiar to you, but I'm betting that you are pretty familiar with different animals that are considered crustaceans. Like, what kind of animal is this? This is a crab, and this is a spider crab, and actually one of the largest types of crustaceans out there. So some other examples of crustaceans besides crab include lobster and shrimp, and I'm betting that you are pretty familiar with those. So what are some of the features that make crustaceans crustaceans? What are some of their adaptations? Now, an adaptation is anything that helps an animal survive, that allows them to really thrive in their environment. So what are the things that crustaceans have? Well, one thing that I notice is that they've got all of these legs here, right? Just like some other animals we might be familiar with on land. And something that makes crustaceans unique is they have jointed legs. So that means that their legs aren't really stiff like this, but they're able to move them, which is pretty unique for invertebrates in general. Now, if they don't have a backbone, what do they have instead? So what I'm getting at is, does this look like a really soft animal to you? Soft and squishy like those jellies that we were looking at? No, right? They have something else to help give their body structure and help protect them. So they have, instead of a skeleton inside of their body, they have what we call an exoskeleton. If you want to say that with me, exoskeleton. And that just means, again, it's like a skeleton on the outside. It is not the same material, though, as our bones. So this exoskeleton is made out of something called chitin. And it fuses with lots of different proteins, and it really creates a strong structure that gives their body form and helps keep them safe from predators. So let's think a little bit about what are some of the drawbacks to this and what are some of the benefits. Well, benefits, of course, include that it is a nice, safe structure for them, and they have these joints here, so they're still able to move, still able to have some flexibility. But one of the drawbacks, or what could be considered a drawback, is that their exoskeletons don't grow along with them. So as we're growing, our bones grow with us, right? So we get bigger and our bones get bigger. Exoskeletons work a little bit differently. And I actually have some examples of exoskeletons under my camera over here. If we want to take a quick look, we can look at some exoskeletons of two crustaceans that we have here at the aquarium. If we can switch over to that view. Awesome, thank you. So, okay, so here is the exoskeleton of I think, spider crab here, and this is a spiny lobster. Now, while you look at these, you might think, well, those look, are those alive? Are those dead? Not exactly. So this is or not at all, actually. These are, these are molts. So as crustaceans get bigger, their exoskeletons don't grow with them. Instead, they have to go through a process of molting, which means shedding out of their old exoskeletons. And then in their new molts, they are even bigger. So these are molts. So that means that these two animals, they grew a little bit, they sort of molted, they shed out of them, they molted, and they left them behind. And it's a really great look at what their exoskeletons look like while they are on their bodies. So if I were to turn this over, we could actually see it's hollow on the inside because crustaceans have really soft, squishy bodies on the inside of their exoskeletons. Now, there's a couple of advantages to this, to having this sort of way of growing. So one of them is that they are able to regenerate. So we can see, especially on our spiny lobster here, they've got all these legs and all of these little, joints here, which can be kind of fragile out there in the ocean. And so if they happen to lose one, well, the next time that they molt, they can regenerate it. So that's pretty cool. Can we regenerate any of our limbs if anything happens? Not so much, right? So that is one huge advantage to being able to molt. One of the drawbacks, though, is, well, after they molt, immediately after they shed out of it, their exoskeleton hasn't hardened yet. It's actually pretty soft. And so that means that they're really vulnerable because remember, this exoskeleton is something that helps protect them. And so while they are in the process of waiting for their exoskeleton to harden, that can be a time where they're vulnerable to other predators, and they'll stay very still and really try to hide so that other things won't see them. Now we have a video that shows this process of one of our spider crabs here, and we can see it's starting to, this is our crab wiggling out of its molt here. And we can see it's pulling out all of its little legs right out of this space. And it's really being very careful as it does this. So we've really taken our time, or sped this video up. This is a process that actually takes about 40 minutes, but we've sped it up so it's only a couple of minutes. So again, this is another drawback, is that the time it takes to molt. But another benefit of this process is that crustaceans can grow their entire lives. They continually go through this. So they tend to molt a lot when they're really young because it's, advantageous to grow as quickly as possible. But even fully grown adults will continue to go through this. It's much harder to measure their growth, but it is a pretty cool feature of this process in general. Oh, look at it wiggling out all of its little legs. And if you have any observations or anything you'd like to share, then go ahead and let me know what you're noticing. I'm really seeing how it has to, it's hard work to get all those legs out. So again, spider crabs are the largest type of crustacean just in terms of length. Their legs can get up to 13 feet. So not in terms of weight. There's other crustaceans out there that weigh more than them, but when we look at the length of their legs, it is the largest. So pretty amazing. All right, I see a couple of questions have come in. Are they more or less aggressive than fish? I wouldn't characterize most crustaceans as aggressive, but again, it really depends on the species that we're talking about in general. So there's definitely some very territorial fish out there that will spend a lot of time defending their area, their territory, where they live. I imagine there's some aggressive crustaceans out there, but I would think that fish in general are more aggressive. Oh, and how often do they lose their shell or molt? So again, for all crustaceans, when they're really young, they will molt quite frequently to help them grow as quickly as possible. And then how often once they're adults depends on the species, but for the most part, I would say about once a year is pretty typical. And molting also has to do with how much nutrition is really available for them. It's an energy intensive process. Remember, they have to grow. So if they're really healthy and in a healthy environment, they might molt more often. But for example, our horseshoe crabs and spider crabs and spiny lobsters, once they're older, I would say it's only about once a year. Oh, and another advantage to molting is that they can actually eat their molt afterwards. So that is another form of nutrition for them and really helps them grow, gets through the next process a little bit easier. And Bennett is wondering, do squid count as invertebrates? And yes, they do. Squid are definitely invertebrates. They are part of a group of invertebrates called cephalopods. Oh, hello, little bobbin squid. So this is a deep sea squid that we have a picture of here. Thank you, Jen, for pulling this one up. And actually, we could talk about cephalopods next, since that question did come up. And Lily Ann was asking if they eat their shell. And yes, so crustaceans will eat their molt once they are done with it. So yes, again, another good form of nutrition for them. Okay, so squids are in a group called cephalopods, which again is sort of a big word. And all that really means is they have big heads. Can you see what I'm talking about when we look at this picture here? Looking at this head? So what other cephalopods are there that are related to squid? So I would say probably the most famous one are, of course, octopus. So here's a great picture of an octopus. And we can see, again, it's got that head there. But there are two other cephalopods that I would like to highlight because they don't get as much airtime as our octopus do. So we also have Nautilus is considered a cephalopod here. And this is a more primitive cephalopod because what do you notice that was different between the squid and the octopus and our Nautilus here is this shell. So squid and octopus, they no longer have that external shell. Squid instead have what's called a pen, which is a remnant of the shell that does help them give shape, same material. But a nautilus does still have its shell. However, just like our octopus and squid, we can see it's got that big eye there. So that's letting us know it's got that head, which is a defining feature for this group. And then the last cephalopod, personally, I think this one might be my favorite, although it does change a little bit depending on my mood, is our cuttlefish. Oh, look at this cuttlefish. Now, it's pretty easy to confuse cuttlefish and squid. They do have similar body shapes. And I would say that the easiest, and even some cuttlefish are called squid just in their common name. So I think that's another, confusing, another way we can easily be confused. But the way that we can really tell the difference is watching them swim. So squid, they do what we call jet propulsion. So they pull water into their mantle and then they push it out of a part of the body called a siphon. It's like a little tube. We can see that on octopus as well. And that really sort of helps them move through the water. They'll move pretty straight. Remember, they have that pen, which helps give their body structure and allows them to do that. Cuttlefish, instead, they use these fins all around their body here. So they're not as good of swimmers as squid generally are. They are sort of go through the water a little bit. They bob through the water a little bit more than squid do, and that's a reflection of how they're able to swim. So that's one way to tell the difference. If you ever happen to be in the ocean and, see what you think might be a squid or a cuttlefish, oh, beautiful. So we can see it's like ruffling its fins right here, and it's not sucking any water in at all. I don't know if we have any video of a squid so we can take a look at the difference, but that's okay. Okay, so I'll continue talking about cephalopod features in a moment. Lydia is wondering, what do jellies eat, and do they lay eggs? So jellies, here's a great picture of a jelly. So what do jellies eat? Well, it does depend on the species of jelly because we have really small jellies and really big jellies. But what they all do is they use their tentacles to catch their prey. So what is a feature of those tentacles? When you think of a jelly, what do you think of? Stinging, right? So all jellies do have stinging cells along their tentacles, and they use that to catch food. So anything that drifts by, they're able to sting and eat, they will. So some jellies eat really small things like plankton. For example, our moon jellies that we have here at the aquarium, they have really tiny tentacles right here. You can barely see them. They're all along the bell here, though. They're really small. So we feed them brine shrimp, which is really, really tiny type of shrimp. But the sea nettles that we were just looking at, they have incredibly long tentacles, and they would be able to eat other jellies or possibly fish as well. So it does depend on the type of jelly we're talking about. But Lydia, I'm glad you asked about jellies because this is another example of an invertebrate, a very simple invertebrate, and they are very closely related, believe it or not, to coral and anemones. So all three of those animals are in a group called Cnidaria, and all of them have those stinging cells. So when we think of jellies, we often think of the stinging cells, but anemones and coral also have those stinging cells as well, even if we can't always feel them when we are touching them. All right, so great question. And I see a note here. We can go back to our cephalopods. I think we can talk a little bit more about them and then maybe jump into another group. Oh, hello, Cuttlefish. So I see a note that there's some debate about whether or not the Nautilus is primitive or not. That's new information to me. It just shows us that there is continually research being done on these animals. So that is awesome. What I can say is a shared feature of all of them as well is their intelligence. And what do you see here? What are those? They're arms or tentacles, right? So all members of the cephalopod family also have those tentacles or arms, and we can actually take a look at how they're able to use them. And this is perfect because Ryder and Sean are asking, Shane, excuse me. Oh my goodness, did you see that? Oh, look at it, grab it. So this is a cuttlefish. Again, we can tell by looking at the fin around its body. And what do you notice it's doing? Do you see that amazing color change? So when we think of color changing cephalopods, we really tend to think of octopus, right? But other members of this family also are able to change their color. And so they do it for a number of reasons. When we saw that cuttlefish hunting, it was likely showing it was excited, or maybe it was trying to confuse the prey by changing its color. So there's a number of reasons that they will change their color, and it's not only octopus that can do it. Okay. Now, Ryder and Shane were asking how strong are octopus suction cups. And again, it's going to depend on which kind of octopus we're talking about. But one cup of, I think this is the giant Pacific octopus that we're talking about, can lift up to 10 pounds, which is pretty incredible for one little cup here. So that means one of these little suction cups, when fully grown, can lift 10 pounds. So if you're able to maybe find a 10-pound weight and lift that up, and you can really see what that feels like, you can see how strong. Perfect. So here's a giant Pacific octopus here. We can see it's covered in these suction cups, and I think they have up to 250 per arm. So that means that every single one of those little suction cups can hold up to 10 pounds. Pretty incredible. And I also see a question from Ryder and Shane. Do suction cups have teeth? On squid, yes, there are definitely some species of squid out there that do have teeth on the suction cups. I think that's a deep sea species of squid, the Humboldt squid. That is a very predatory type of squid. And so they have those teeth on there. Perfect. Here is an image of the Humboldt squid. We can see, though, that the diver is with them, so not really much danger for us. But those teeth suction cups is really going to help it grab its food. I would say, especially in the deep sea, food availability is a huge issue for animals that live down there. So they really need these adaptations to help them get the food as quickly as they can when they are able to. And having teeth on the suction cups is really going to allow them to do that. So I also see a question that is, why are cuttlefish called cuttlefish? Because they're so cute and cuddly, right? No? Okay, so it is because they have what's called a cuddle bone in their back. So similar to how a squid has that pen, this is a similar feature to the squid. So it's going to allow them to have that same structure there as well. Now, this is a great image because we were talking about color change, and I want to talk a little bit about how they are able to do that. So one thing that I'm noticing here on the cuttlefish is that it also looks very textured. And this is also a part of how they're able to, or a part of how they're able to change their skin. So octopus and cuttlefish and squid all have these special skin cells called chromatophores, which is what they open and close. And that's what allows them to change their color to either match their environment. Camouflage is that's a main reason why they change their color. But like we observed in that video of the cuttlefish hunting, there's other reasons that they change color as well. But these skin cells not only allow them to change color, but it also allows them to change the texture of their skin. And that's another pretty amazing feature. So they not only can change their skin to match the colors, but match what the texture is. So if they're in a rocky reef, they can look like a rocky reef. If they are in a smooth, sandy area, they can also match a smooth area. So that's just another amazing adaptation that cephalopods have. Oh, and we have a video that we can pull up here. So here we can see an octopus, and we were talking about movements, and I just want to point that out really quickly. So that's the siphon, and that's their mantle. So they're able to, oh wow, how can I even talk about anything else when it's doing that? Amazing. So we saw it go for completely different colors and texture. So it started out red. You saw that dynamic color change. And then if we look at the textures here and then look in the surrounding environments, you can see how it really matches it. Can we watch it one more time? I feel like I was focused on how it moves. So it starts completely smooth and red. It sinks down and then completely changes its form and coloration to match that habitat. Amazing. Cephalopods have so many incredible adaptations. Another thing that they are all known for is their intelligence, which I mentioned. So octopus are also known for being escape artists and problem solvers. So they can use their arms to manipulate things around them. They can move their arms independently of one another. And that is another just incredible adaptation that they have. I think Jen is pulling up a video of some problem-solving octopus that we have here at the aquarium, so we can actually see them trying to get out of a box. So this is another amazing thing about them. Now, I don't know if squid and cuttlefish have the same capabilities because their arms do look a little bit differently, but I do believe that they are known for being intelligent as well. I think that there's just not as much research that's been done on their intelligence. So it's hard to compare them. But just because the research hasn't been done doesn't mean it won't be. And just because they don't have arms like octopus doesn't mean they aren't as intelligent. So I think that's important to remember when we're thinking about cephalopod intelligence in general. I think octopus get a lot of the attention when we're thinking about them. Oh, I see. I missed a question here anyway, so I'll answer that while we're looking for that video. Hannah is wondering, where are jellyfish heads? Great question, Hannah. Where are they? So, when we're thinking about animals like the jelly, do we see eyes and a mouth? Not exactly. So, as invertebrates like this, and very simple ones, they don't have heads like we do. So, jellies don't have eyes, complex eyes. So, that's why we're not seeing any. They are able to sense light. They have a special structure around their bell, which is what this part is called, that does allow them to sense light and motion. But they don't have eyes in the same way we do. They do have a mouth, though. Any thoughts on where their mouth is? So their mouth is right in the middle here. So again, they have these tentacles all around them, and they have those ruffles are called oral arms. That's what pulls food all the way up into their mouth. And if we take a look at what's on top of their bell, you might notice there's 4 little like half circles, what it looks like. So those are their stomachs. They are lucky enough to have 4 stomachs, my friends. Imagine how much more breakfast we could have if we had four of those. So yes, their mouth is right in the middle there, and then that feeds right into their stomachs. So great question, Hannah. That's okay. So we can't find that video of the octopus, but you can look that up. That's on our YouTube channel. So if you wanted to see an octopus trying to get out of a little box and look at some of the enrichment that we give our animals, that's a great video to watch. But that's okay because you know what? There's 90% of all of the animals in the world are invertebrates. So we have plenty more animals that we can talk about for our last few minutes. So we spent a lot of time talking about cephalopods and crustaceans, 2 completely different types of invertebrates. We even talked about jellies, which are cnidarians. I think I would be amiss to bring up a group that we call echinoderms. Said that a little bit weird, which is a group of animals that we have a lot of here at the aquarium that if you are lucky to visit us, you can even touch. And if you're saying, what? You want me to touch this spiky little ball? Yes, I do. I do want you to touch this. This is what we call a sea urchin. Now, again, the name echinoderm, that kind of sounds like a big word. So that word just means spiny skin. And when we're looking at this animal, we can really understand where it gets that name from, right? Because again, a lot of people see this and a lot of animals out there see this and they go, whoa, I don't want to touch that. So sea urchins do have these spines all over them to help keep them safe. It's a pretty great adaptation that they have that to deter predators. And another feature of echinoderms in general that's pretty useful, especially for these spines here, is regeneration. So if they do lose a spine through predation or maybe just moving around on the rocks, they can regrow those spines. Now, something else that I do get asked a lot about these urchins when people are touching them here at our touch labs is, where are their faces? Where are their eyes? Oh, here we go. This is a really great picture of our urchins with their tube feet all out. So that's another feature of this group in general. So do you see any eyes? Not so much, right? So they also do not have eyes, and instead they rely on their senses using these tube feet. But they are able to sense light as well, just kind of like our jellies were able to. Now, if we see what it's on, if you're to take a look at this picture, it's sitting on a piece of kelp, its favorite food. These are herbivores. So its mouth is underneath its body. So it's completely flat. They sit on their mouths, and they have those tube feet underneath as well that help them move around and also stick to things if they need to. And then they'll just sort of sit on a rock and scrape up all of the algae that they can find. And if they're lucky enough to get a blade of kelp, that's a very exciting day for a sea urchin. They do love to eat those. Now, here we go. Here's the mouth here. So they have what's called an Aristotle's lantern mouth, which basically means it's just teeth that are it's a 5-part tooth, I guess. I don't know how else to say it. That sort of can scrape off all of the algae that they find on rocks, We can see all of those tube feet surrounding the mouth right here. So again, those act like little suction cups and allow them to move around. It's like they have tons and tons of little feet that allow them to move around tide pools and other rocky areas that they live. My friends, I would love to talk more about echinoderms and invertebrates in general because we have so many of them here at the aquarium, but we are just about out of time today. I do want to let you know before you go, Ocean Rangers, that we have a really awesome activity for you to do at home that I hope that you will participate in. In fact, I even participated in it. So you could make... Oh, oh, we can't see the color of it, but I promise you it's green. So you can make some slime that would feel somewhat like an octopus might feel, or maybe represent the ink that they shoot out when they're feeling scared. So I encourage you to make some at home. It's a really fun and easy project. And you can tune in tomorrow at 11 a.m. Ocean Rangers. I'm not sure what our topic is, but I'm sure it's going to be awesome. So thank you so much for tuning in today, and I hope you have a great rest of your day. It happened a couple times. It's weird. It usually doesn't. That's okay.